Stop talking. Go ahead, Hillary. She's on her way.
Thank you.
All right, so focusing on more of the multiplication of the radicals right now. So like I said before, we already did a basic warm-up on multiplying radicals where it was just a simple, let me multiply these two radicals together or these three radicals together. So there are other times when you have a single radical and it's raised to a power, which is no different. So if I give you something like 2 square root of 5, and I'm taking that entire radical and raising it to the second power. Now, you could write it out. You could go, oh, 2 square root of 5 times 2 square root of 5. Or you could follow our rules when we've got something that's raised to a power outside of the parentheses. What do we do? Technically, what exponent happens to be here? What exponent is in front of that 2? Or behind that 2? Jordan?
0.
No, because if anything had a 0 exponent, what would it always equal? 1. It would always equal 1 if it had a 0 exponent. This does not equal a 1. This equals a 2. So in order for it to equal a 2, it has to have an exponent of a 1. Okay? So what we could technically do is take this exponent that's on the outside and distribute it to each individual term. Distribute it to the 2 and distribute it to the square root of 5. So if I were to do that, distributing the exponent to each, that would become 2 squared, and then the square root of 5 squared. Now, we've already talked about what would happen. We know what 2 squared is. What's 2 squared? 4. And we've talked about what would happen, hey, if you have a square root and a square, they are inverse operations, so it's like neither one exists, isn't it? So the square root of 5 to the second power is just going to equal what? 5. It's just going to equal 5. That square is going to get rid, or inverse, it's going to be the inverse to that square root, so it's like neither one ever existed happening. Okay, it makes sense, too, because if we did square root of 5 times square root of 5, that would give us square root of 25, and the square root of 25 is 5. Okay, so now we have the expression 4 times 5, and what is 4 times 5? 20. That's our final answer. I want you guys to go ahead and do the following on your own. After you're done with the notes, you may. Hillary, who's your house? Slytherin? Okay, here's yours.
Wait, did you get points for
I did. I'm not quite sure. I'm assuming right now. I would assume. All right, who can tell me what they got for their final answer for problem number 2? Elisa? 252, very good. If you were to distribute the square root of 2 to each, or the exponent of a 2 to each, this would become 6 to the second power, square root of 7 to the second power, which would just become 36 times 7, which would then become 252. Oops. Okay, what about for problem number 3? What did you get for number 3, Jordan?
125.
125. And if you distribute the exponent, that becomes 5 to the second power times the square root of 5 to the second power, which becomes 25 times 5, which is 125. Okay, and what about our last one, Heaven? 32. Again, if you distribute, that's going to become 4 to the second power times the square root of 2 to the second power. 4 to the second power is 16. Square root of 2 to the second power is just 2. And then 16 times 2 is going to give you 32. All right. So that's the easy stuff. Let's go on to something a little bit more intense. Not going to say variable, but intense. And we're not going to focus on the variable part. Well, actually, yeah, we could throw in a variable or two. No, let's throw in just 2 problems with a variable in it. It's not that big of a deal. Come on. Don't be such a wuss.
That's illegal. That's illegal. This game.
I'll do one with you, and then you can do one on your own. So how about, let's take a look here.
Pink.
We're going to do the variable, but this time, hey, if we do it to this. And now how many terms do we have here? 2. Right? We have the square root is considered to be 1 term. That radicand is all together. Then we distribute it to this x, and we distribute it to this 6. So we now have 6 to the second power, x to the second power, square root of 3x to the second power. This now becomes 36 times x to the second times 3x. We then can go ahead and multiply 36 times 3. And we can also multiply x to the second times x. What's 36 times 3? 108. And then what's x to the second times x? X to the third. See? Not that hard. Okay? Let's try some on your own.
Ice cream tastes like.
Shh. Quiet. Try that one on your own. Relax. Shh. No.
It's multiplication.
Well, you're distributing. That's multiplication.
Oh.
Hmm? No, because it's distribution. Distribution means you multiply. Because, see, this technically had a 1 for the exponent, right? But when you distributed, it became a 2 because you did 2 times the 1. All right, who could tell me what they got for number 6 then? What do you think, Mateo?
18x to the 7th.
Very good. 18x to the 7th is correct. When you distribute, again, guys, distribution means that you're multiplying to each. Because each of these originally, when we focus on it, anything that wasn't inside the radical was a whole for their exponent, a one whole for the exponent. Do you guys know what a square root's exponent actually is?
No.
So, we're going to stop for a second. If I were to say, oh, 5, or the square root of 5, that technically is an exponent. Arham, you said you know what the exponent is? What would the exponent be for the 5?
It will be 2.
No. So if it's just a square root of 5, the exponent is technically what? What do you think?
-1.
Not a 1.
-0.
So this exponent, I could write it as 5. It would have an exponent of a half.
Yeah, I got that.
So here's why if I take the square root of 5 and then I square it, it's technically the same thing as saying, hey, I've got 5 to a half power, and I'm going to square it. Well, what's a half power times 2? 1, which gives you 5 to the first power, or just 5. That's the reason why that works, because a root is a fractional exponent. So a cubed root, guys, quiet. A cubed root is just 1/3 as an exponent. Okay, a fourth root is a fourth as an exponent. So if you guys want to test it out, pick a perfect square. 25, okay. So take the value 25. I want you to take your calculators. What I want you to do, take a perfect square like 25. And you're going to put an exponent, so you're going to use your exponent button and put it in as a fraction of 1/2. And when you do that exponent, it will equal 5.
That is scary.
See?
But, whoa. What if you did 0.5 as the exponent?
0.5 is the same. Not right now. All right. So, when we're distributing, this has an exponent of a 1, so this now becomes 3 to the second power. Stop talking. That x to the third with another exponent of a second, you're multiplying 3 times 2, that becomes x to the 6. And then the square root of 2x is now going to become the square root of 2x to the second power. 3 to the second power is 9. X to the 6 is going to stay x to the 6. And then the square root of 2x to the second power now becomes 2x. Now we multiply the numbers, 9 times 2, and we multiply the variables, x to the 6 times x. This becomes 18x to the 7th, because when you multiply by the same base, you add those exponents. Okay? All right, now let's go ahead and move on to some more forms of distribution. Really? Did you just done it that? All right. If we've got the square root of 2 and I'm wanting to multiply it by 5 plus the square root of 12. This is distributive property. What we're going to be doing is taking that square root of 2 and we are going to distribute it as multiplication to each component. Stop talking, please. So we're going to do square root of 2 times 5 and square root of 2 times the square root of 12. So square root of 2 times the 5, which one should I write first, the square root or the non-square root? The non-square root. Very good. So I'm going to write it as 5 times the square root of 2. Well, 5 times the square root of 2 is just 5 square roots of 2. Then I'm going to go ahead and multiply the square root of 2 times the square root of 12. What is the square root of 2 times the square root of 12?
The square root of 24.
The square root of 24. Okay, so now I've got an addition problem. Are they like radicals? No. Can I simplify the square root of 24? Yes, I can simplify the square root of 24. Who can raise their hand and tell me the two factors to use for square root of 24? What do you think, Elijah?
2 and 6.
2 and 6?
Oh no, I see it 4 and 6.
4 and 6. So we've got the square root of 4 and the square root of 6. Quiet. Guys, you realize that this is recording. I've also been sending these videos to the other teachers so that they can use them. Shh. Now we're going to simplify. The square root of 4 can simplify to a 2. We've got 2 square roots of 6. We still have that 5 square root of 2. Can we combine those? No, because they are not like radicals. They are not like radicals, and therefore we cannot combine them. So this is as finalized as our answer can possibly be. 5 square root of 2 plus 2 square roots of 6. Let's try another one. Colin, it's the second time I've asked you to take your hood off. Shh. Oh, my bad. All right. So we have the square root of 3 times the quantity of square root of 3 minus square root of 5. Again, we're just going to distribute. So we're going to take the square root of 3. We're going to distribute it to a square root of 3 and distribute it to the square root of 5. So we've got square root of 3 times the square root of 3. What is square root of 3 times square root of 3? Square root of 9, which is 3. So technically I don't have to sit here and write, oh, it's going to be a square root of 9 and then it simplifies to 3. I don't have to do that. If I know that they are identical square roots, meaning it is a root of the exact same radicand, then I don't have to sit there and multiply it out. I can just remove the root sign and keep the radicand as my new value. Okay? All right, square root of 3 times the square root of 5, that you do have to multiply. So what is that going to equal? Square root of 15. Can I factor square root of 15?
No.
No. Square root of 15 does not have any perfect squares that can go into it. So square root of 15 is the final answer for that portion. And what operation is going to go in between?
Minus.
Minus, subtraction. And here's your final answer. Do that one on your own. right, you can tell me the final answer. Akshaya? Yes. 4 square roots of 3 minus 3 square roots of 6. If we go ahead and we distribute, so we're going to do square root of 6 times the square root of 8. Square root of 6 times the square root of 8 is going to give us a square root of 48. 48 can be factored. It's got a perfect square of 16 and a non-perfect square of 3. Square root of 16 is going to give us 4, so we have 4 square root of 3. Then when we multiply square root of 6 times the 3, so that's 3 times the square root of 6, which is going to give us 3 square roots of 6. Square root of 6 cannot be factored. It just comes straight down as 3 square roots of 6, and it's subtraction. So there's our final answer. Okay. Try that one. Who can tell me what they got? Lena? Very good. 7 square roots of 15. If you go ahead and you distribute, so if we do 5 square roots, or a square root of 5 times the square root of 27, the square root of 5 times the square root of 27 is going to give us a square root of 135. Well, we can factor that out. Who can tell me what are the factors of 135 then? So, or Lena, go ahead and tell me what those factors are going to be. Very good. So square root of 15 and square root of 9. Right? Because 15 times 9 is also going to give us 135. 9 is the largest perfect square that can go into it. When you simplify that, it becomes 3 square roots of 15. Well, then we distribute the square root of 5 to the 4 square roots of 3. So the only things you're actually multiplying together are the roots. You can't multiply with the 4. The 4 is outside of that square root. But you can multiply what's inside the square roots. Colin, third time, hood off. Miles, hood off. That's going to become 4 square root of 15. We've got a nice little plus sign in between it. So I can actually go ahead and combine them because they are like radicals now. So what's 3 plus 4? 7 square roots of 15. Okay, we're going to do one more example with a variable in it, and then I'm going to go ahead and give you guys your assignment. I'm not going to get to FOIL today, so we'll do FOIL tomorrow. Aww. Who? Her? She just likes the word FOIL.
It's like foil.
It's FOIL. Goodness gracious. What number was that? Was that number
11.
11? So this is number 11 now? All right. Shh. So let's say that we've got the square root of 2x, and we're multiplying it by 3 minus the square root of 6x. So I'll do this one with you guys because I want to have you get onto your assignment. But if we multiply square root of 2 times the 3 is going to have to go in the front. So we're going to have 3 times the square root of 2x. That's as simplified as that's going to get 3 square roots of 2x. Well, then we're going to go ahead and multiply the square root of 2x times the square root of 6x, which means we're really just multiplying 2 times 6 and x times x. Well, what's 2 times 6? 12. So we have square root of 12. And then what's the x times x? X to the second, or x squared. So we have square root of x squared. 12 can be factored, can it?
Yeah.
What are the factors of 12?
4 and 3.
4 and 3. Okay, so square root of 4 is going to give us a 2, so we now have 2 square roots of 3. And then we can simplify the square root of x squared. What is that going to simplify to? X. So this now, the whole thing becomes 2x square root of 3. 2x square root of 3. And we still have the front portion, which was 3 square root of 2x. Can we combine those? No, because they're not like radicals. We have a square root of 2x and we have a square root of 3. They're not the same. That's as finalized as that's going to get. All right. Your assignment. Just so you guys know that these are B's, I'm just going to make them capital B's. What? You know who also made that revelation? My daughter. She's 4.
She's 4.
You said it, not me.
But some 20-year-olds do saying that kind of stuff too. But small print said,
Who's that? I don't know. Right.
The more that you ask, the more problems I give.
Bro, Johnny was talking about monkey scales. No, I remember like last year there was. Oh my god, I know.
Shh, quiet. How about you all get quiet and you just copy this down? No. Yep. After class is over, sure. It's not that important. Don't